Today we're doing 4.1, simplifying rational expressions. So a rational expression, just what that means, has the word ratio in it. So it's going to be set up as a ratio, and that's it. Just a single ratio where you have something over something else, a fraction. Okay, we're going to have, for the most part here, we're going to take a polynomial, which is what we were doing in the last unit, and dividing it by a polynomial. Which will be our numerator over our denominator. And that's going to be our rational expression. When you see expression, you typically don't have an equal sign. It's not an equation. It would be just one side of the equation would be the expression. Okay? And all we're going to be doing today is simplifying these, and all the rules that you ever applied when you simplified fractions, which you guys can do. You do it really easily without even thinking about it much. Those same rules apply. Okay, so for example here, if I asked you to simplify, which is what today is going to be about, just simplifying, you're going to divide out, you're going to reduce, you're going to cancel all the common factors. So divide out or reduce, or sometimes we'll say cancel, okay, the common factors. Of n and d. Anything in the numerator that's exactly the same in the denominator, you can cancel away. We're going to have some what they call excluded values. The excluded values are when the denominator equals 0. Okay? And so what we're going to say is the denominator can't be 0. Those are going to be the excluded values. Whatever makes it equal 0 are going to be the excluded values. So if it asks you to find those, just look at any point, any number that causes the denominator to be 0, we'd have to exclude. Whether we can cancel it or not, we're going to exclude it. Okay? So back to what you know really well. You know how to reduce pretty easily 10 over 15. You do it without really even thinking about it much, right? What's that reduced to? 2/3. Now what did you do? Think about what you did. You divided by 5. 10 and 15 shared a common factor of 5. Okay, so now these are going to look a little different because we're going to be throwing letters in, but I could write 10 as 2 times 5, and I could write 15 as 3 times 5. When it's multiplied, and that's really important, when it's multiplied like this, that's when you can reduce. Okay, and we're typically going to put parentheses around it, but it's just as long as the terms are all multiplied, that's when I can reduce this. Okay, and I can get an answer of 2/3, which you know, you've done that probably what, since 5th grade maybe? Reduce fractions. Okay, here's where it gets a little tricky. Is 2 plus 5 divided by 3 plus 5, can I cancel those 5s? Okay, if I was just adding those, I'd get 7 on top and I'd get 8 on the bottom, right? That's what that would add up to be. The way that's written, 2 plus 5 in the numerator, 3 plus 5 in the denominator. Can I cancel those and equal 2/3? Is 2/3 the same as 7/8? No, that's not the same. Okay, so you cannot reduce these. That's not allowed when you're adding. It has to be multiplying. The 2 and the 5 are tied together by that addition sign. So the only way I could reduce this is if I could cancel 2 plus 5. The only way I could reduce that is if I could cancel 7. And the 3 and the 5 are tied together with that addition sign. And the same is true for subtraction, because subtraction really is just adding the opposite. It's addition. Okay, so if they're tied together by a plus or minus, they're linked together. You have to be able to cancel the entire thing to be able to reduce. Okay, because we're going to go to, well, let me show you one other thing. If you had 5, say times 2 plus 3 over 6 times 2 plus 3, this is the case where actually I could reduce. I could reduce these 2 plus 3's because they're tied together and they're being multiplied here. This would be 5/6, and I'm going to show you that this would equal 5/6. If I went ahead and distributed here, I'd have 10 plus 15, right? Distribute the 5. Distribute here, you'd have 12 plus 18, and then you'd add that all up and get 25 over 30. And then you'd think of common factors of 25 and 30, and you'd say, oh, I could take a 5 out of each of those, reduce those 5s, and get a 5, 6. Well, it would have been a lot faster if right here I had just canceled these and got an answer of 5, 6. Alexi?
Do you have to just like distribute when you're? Okay.
No, so, well, okay, we also could have done 2 plus 3 is 5, 5 times 5 is 25, 6 times 5 is 30,
That's what
same thing, yeah, so, so any of those, we're following the rules on any of those, that's legal. But right here, I could have reduced and had the answer really fast, okay? This would be this 2 plus 3 over 2 plus 3, which really is 5 over 5, but that would have been a common factor that I could have canceled. So what we're going to be doing, though, is throwing in letters like this. 5 times x plus 3 over 6 times x plus 3. This I can reduce as long as I can cancel that whole x plus 3. That plus sign ties those guys together. You got to cancel the entire thing. So this I could reduce this and get an answer of 5, 6. Okay? What I can't do, if I had x plus 3 over x minus 2, I can't cancel those x's. And that's where we mess up. If we're going to mess up here, we think, oh, cancel these x's. No. This plus ties the x and the 3 together. You have to cancel the entire thing. This minus ties the x and the 2 together. You have to cancel the entire thing. And if you had multiples, like if you had x squared plus 5x plus 6 over x squared plus 5x minus 7, I wouldn't be able to reduce anything from that, because that plus and that plus tie all 3 of those together, okay? If I could factor it, though, and get 2 factors where the factors were exactly the same in the numerator and the denominator, then I could reduce. Okay, so we're looking for common factors. You have to follow the rules. The rules say I can't just cancel those x's. And I'm going to ask you over and over and over in this unit, can I cancel those x's? And I want a resounding, no, you can't do that, okay? All right, so here's the directions. Simplify and state the excluded values. Simplify and also state the excluded values. Yes. We good? Okay. Number 1. 21a squared over 3a cubed. Okay. We're going to write this out a really, really long way. I'd like for you to get to the point where you don't have to write this out a really, really long way, but I want you to see that we're following the rules by doing this. Okay. The really, really long way would be to factor 21 completely as 3 times 7. And then a squared is really a times a. So what I'm showing is that all of those are multiplied together. 3 times 7 times a times a. That's good. That's when we can think about reducing. Okay? Over. In the denominator, then I'd have 3 times a times a times a. And again, ultimately, I don't want you to write it out like this, but I'm just showing you how we can do it. Now, because this is all multiplied, any common factors in the top and the bottom you can reduce. So I can cancel a 3, and I'm dividing by 3 in both cases is what I'm doing. I can divide both of these by an a and another a, and then what's left on top? 7. What's left on the bottom? A. You also could have looked at what's the common factor for the 3 and the 21? 3. And if I divided 21 by 3, I'd get 7. The common factor here is a squared. A squared goes into both of these. So I could divide an a squared out, leaving just 1, and then divide an a squared out there, leaving a. All right? This is simplified. Now, as far as the excluded values, what you want to look at is your denominators. I have a in the denominator, a cubed, and all these a's, and then I end up with a. What value for a would cause that denominator to be 0? Anything? Is there anything I could plug in for a that would make that denominator 0? There's 1. What is it? 0, right? That's the excluded value. A can't be 0. Okay, so when it says excluded values, that's what you're going to do. Could a be 3? Sure. Could A be negative 3?
Yeah.
Sure. Any of those are fine. It just can't be 0. All right, let's do another one of these. Number 2, 16d squared over 4d plus 8. Can I cancel these d's? No, you can't cancel these d's. You can't, okay? This plus sign ties the 4d and the 8 together. To cancel right now, I'd have to cancel the whole 4d plus 8, and I don't have a 4d plus 8 in the numerator, okay? So what I'm going to do is in the denominator, I'm going to pull out a GCF. I'm going to leave the numerator as 16d squared over. Now let's pull out a common factor of 4. What would be left? D plus 2. Okay, now, once this is multiplied, this 4 is being multiplied to this. I could reduce the 4, or I could reduce the d plus 2, right? Or I could reduce any part of the 4. But I think I could cancel the whole 4, right? The 4 will cancel into the 16, right? I could take a 4 out of the 16, leaving 4. So I would have 4d squared on top over d plus 2. Is there any part of this denominator that I can reduce? Can I reduce just part of it, the d and the 2? No. You have to cancel the whole thing. Okay, so since I can't, that's it. You got to leave it like that. That is simplified. Okay, now as far as excluded values, what would cause the denominator to be 0? I would look right here, right? That's the easiest spot. It's going to be the same thing because we just factored it. D equals what? Well, set this equal to 0. When d plus 2 equals 0, what does that equal? It's that whole opposite thing again. D can't be negative 2. It can't be negative 2 here. Can't be negative 2 here. And look, if you plugged in negative 2, that's what makes it 0. Anything else is okay. All right? Let's try another one. Number 3, 2n minus 3 over 6n minus 9. Can I cancel those n's? Can I cancel the 3 and the 9? No. You can't do that. These are tied together. I have to cancel the whole thing right now. Okay, but we can factor the bottom, right? The top's not going to change. It's still going to be 2n minus 3. But from the bottom, I can pull out a what? A 3. What would be left? 2n minus 3. This is where you can reduce because I can cancel that whole thing. Those things are tied together, and really I will pretend like this has parentheses around it. Those are tied together, right? This I can reduce, this I can reduce, and so am I just, what am I left with though? What ends up on top? When you're reducing, you're dividing. So what's 2n minus 3 divided by 2n minus 3? What's there? A 1. Yeah, so there's really a 1 here. So the answer is 1/3. Okay, now as far as excluded values, at any point, you got to look at any point. These two are equivalent, so let's look here because it's easier to see. What would make that denominator 0? 3 over 2. It's the opposite of this divided by that. So n can't be a positive 3 over 2. Opposite of this divided by 2. That would be your answer. 1/3 where n can't be 3/2. All right, let's try a little more difficult. 26c cubed plus 91c all over 2c squared plus 7. Okay. So right now, can we reduce anything? No. Nothing can cancel here. Because of these plus signs, I can't do it yet. But we can factor the top. Anybody know what goes into both 26 and 91? There is something. If you had to guess, what do you think it is? What goes into 26? 13, right? How many times does 13 go into 91? If I had to guess, I would guess, you know, just based on these problems, right? I would guess 7. And yeah, it does. So I could pull out, actually at 13, what else could I pull out? A C. Okay. So what would be left from here? 2c squared, right? And then 91 divided by 13 is 7. All right, you guys see it? See what we can reduce? It has to be like that. It's got to be the exact same thing. This whole thing's going to cancel away, leaving what? 13c, right? It'd be 13c over 1, which is just 13c. Okay, and then we need to state any excluded values, and it would be, what would cause 2c squared plus 7 to equal 0? Okay, I don't really know right off, so I'm going to try to solve this. I'm going to take 2c squared plus 7, set it equal to 0. I'd subtract the 7, and then divide by 2. Oops, I dropped my squared. I'd get a c squared equals a negative. That's a problem, right? We're not going to exclude imaginary values. We don't need to exclude imaginary values. So is there anything that c needs to be, any values of c that would cause the denominator to be 0? Mm-mm. You also could have told if I have a squared and I add to it, there's no way that's going to ever equal 0, right? So actually there are none. So this is okay. There are no excluded values. So just 13c, no excluded values. It could be anything. All right, let's try this one. 2x minus 8 over x squared minus 2x minus 8. Can I cancel those 2x minus 8s? Can I do that? 2x minus 8 and that 2x minus 8? No, can't because of this extra x squared minus. All three of those are linked together. Okay, so let's try to factor. We actually can factor the top, right? Adrian, how would you factor the top? Pull out a 2, right? What would be left?
Or x minus 6?
Divide, divide 8. X minus 4. Okay, so you know what I'm really hoping one of these factors is on the bottom? What are we hoping one of them is? X minus 4. We're hoping one of them is x minus 4. Is that right? Would one of them be x minus 4? Would it? If it was, this one was minus 4, what would the other one have to be? Plus 2. Would that be right? You'd have a minus 4x and a plus 2x. Would that give us minus 2x? Yeah. Okay, so now do you see what you can reduce? You can reduce the x minus 4s. Going to reduce those. And I'm left with 2 over x plus 2. Can I cancel those 2's? No, don't do it. Okay, excluded values. What can x not be at any point? Now these two guys are the same. So we're looking for the zeros here. So Ryan, what would be the zeros of this denominator? 4 and negative 2. So neither one of those could be in this problem. Exclude them both. Any questions on what we're doing? Okay. I want to do one more. Is that okay? And then we have an opposite thing to talk about. We're almost done. All right, number 6. A squared minus 3a plus 2 over 3a minus 3. Can I cancel those 3a's? No, they're tied together with some other stuff. Can't do it, okay? You could try, but you get the wrong answer, right? Okay, so we're going to factor the top. I need to factor the top. I know my first term should be a. 2 factors of 2, a positive 2 that add to negative 3. What would that be? Minus 2, minus 1. Okay, so I'm hoping one of these is a factor in the bottom. How would I factor the bottom? Pull out a 3 and what's left? Okay, so can I reduce? Just the a minus 1's, right? Reduce those away, so we're left with a minus 2 over 3. Excluded value, a cannot be what? I'd look right here. Can't be 1. Okay, 1, I totally have this. 4, I totally don't. Tell me where you're at. 1 to 4, please. How do you get those? Zero's a good denominator. What makes the denominator 0? What values of those? 1, I have it. 4, I don't. Tell me where you're at, please. 1. Do you have a question? Yes. What's the question?
Why wouldn't you have 2 on the 6?
Did I write that wrong? Oh, okay. Great question. Why is 2 not excluded? Because it's on top. The only place you can't have 0 is in the denominator. Have I shown you why you can't divide by 0? Have I ever shown you that? Do you know why you can't divide by 0? Like, why can't you do 5 divided by 0?
Because you can't have 1 to 5. You can't have 5 and 0.
Because then it wouldn't be 5. Yeah. And think about in long division, you guys, have you ever tried this? If you go 5 divided by 0 is what it would be, right? How many times does 0 go into 5? 22. 22 times 0 is 0. Subtract the 5. Okay, so now this time, how many times does 0 go into that 5? 27, okay. 27 times 0 is 0. How many times do you want it to go in this time? You know, it's just nonsense, right? So, but like you guys were saying, how would you divide 5 into 0 parts? You can't do that. Okay, so the can never have 0 in the denominator, but 0 in the numerator is okay. 0 divided by anything, you can get an answer for that, right? And be done with it. This way, 2 goes into 0 times, you're done. You can do that, okay? The answer to that is 0, but this does not exist. That answer does not exist, okay? So those are the excluded values. All right, one other thing I wanted to show you real quick before we get to that. If you have opposites, and I know we've talked about this before, but I want to talk about when we're reducing what that would look like. If you had, say, x minus 2 over 2 minus x. So what I want you to notice, one of the signs is positive, the other's negative, and then they trade, right? That's the key. One's positive, the other's negative. They trade. So up here, the x is positive, the 2's negative, and then down here, they're opposite. We talked about this already. We could pull a negative out, right? And so I'm going to pull it out of the denominator. So I'd leave the top as x minus 2. When you pull a negative out, you've got to change the signs of both parts of this. And so the negative x becomes positive x, and the positive 2 becomes negative 2, right? If you distributed that in, you'd get back where you started. And then when you reduce these, what would you be left with? You'd have, when I reduce those, I'd have a 1 on top and a negative 1 on the bottom, making it negative 1. You know what? We're not going to go to all that effort of pulling out the negative. Just when you have something like this, you can reduce that. Just when you reduce it, you're going to say, oh, that's negative 1. Just write it that way. Okay? Again, they have to be opposites. This would not be negative 1, right? X plus 2 and 2 plus x. What would that answer be? That'd be 1, because you could rewrite this as x plus 2. That answer is just 1. So again, one has to be positive, the other negative to do that. Okay, so last example here, let's just try this. Number 7. If I had a minus 2 times a minus 1 over a minus 3 times 1 minus a. Okay, using the idea that I could factor out a negative from really either of them, either one, I could pull the negative out and switch the signs. These reduce, if they're exactly opposites like this, these reduce to a negative. Just be careful where you put that negative. In a fraction, it either will go up on top or it'll go in the denominator, but not both. And then what we could do, since it's here, I could pull it out in front of the whole thing. Negative a minus 2 over a minus 3. That answer is great. Or I could have, this would be the same as, I could distribute the negative in here. 2 minus a over a minus 3 without the negative in front. These two would be equivalent answers, and maybe on a multiple choice you'd need to know that those answers are equivalent. Okay? But the negative out in front actually means you need to distribute it either to the top or distribute it to the bottom. This would be distributed to the top. Okay? So that's all we're going to do. If they're opposites, just cancel and rewrite it as a negative. All right?